Okay, welcome back to the stream. Sorry it's taken so long to get another stream going here. Got really busy with the Open World Builders program and wanted to make sure that I finished strong on the team project at the end. So again, apologies, but we're back at it now, and I think this is a pretty good time to start off pretty simple with the Flow Playground and just going through like the original kind of first tutorials to get everybody started from the same spot. So just 1 second while I do a quick stream check and make sure the audio sounds okay. Okay, apologies. Well, I have no mods. I want to make sure. Oof. Well, I have no mods. I want to make sure that everything sounds good so that at the end of an hour or two long stream, we don't have to redo everything. So, kind of helps keep everyone engaged. Okay, so just to get started, Flow provides a nice little playground that gives everyone a chance to kind of work in a self-contained sandbox environment. So what you're seeing here actually it actually like doesn't exist on the live blockchain itself. So what you're doing here, you're not manipulating anything on chain. You're just basically running some example code that is in your own private little environment. So the playground's a really nice place to kind of flesh out your own ideas and see what's happening. You have a little console that'll give you some feedback when you do end up logging something or running a script. So this will be where you see your error messages. This hasn't been working, this little storage area here, but that might have been fixed since I last used the playground. But this is also super handy once you've actually deployed contracts and started storing things in your account. You'll actually see those things appear in storage, which we don't have in the Visual Studio Code emulator yet. So that's a nice little thing that the playground has that the emulator doesn't. And it's super helpful when you're actually trying to keep track of everything that you have going on in your test environment. On the other side, you have these 4 accounts. It's, I believe, limited to 4 at this time, so some projects will require more accounts because they have more contracts to deploy. At the current time, you can only deploy 1 contract to 1 account. So each account can only store a single smart contract, so that can be a limitation if you're working with 5, 6 plus contracts for your project. But either way, this is a great way to just kind of get started working with the code and also share the projects that you're working on with other people. You have a nice little link that you can actually share when you're done working on something. You can fork other people's code. Also, I should give a huge plug out to Max, Block Trainer. He was on the Voti Auction Part 2 stream, and he's put together some nice tooling in the form of like Chrome extensions that give the playground a dark mode. Otherwise, the white background is a little hard on the eyes sometimes. And this will actually integrate with your GitHub account, so you can, I believe, push your project right to a Git repo and continue working on it from there. So super handy stuff. So shout out and thank you to Max for putting together tools that make our lives easier and our eyes more comfortable over the course of a project. So getting started, we're going to look at just quickly, we're working from the Hello World tutorial. This is found in the docs for the onflow.org. And you'll see this is the first of a few different tutorials. We'll kind of work our way through these over the coming weeks. I'm planning on streaming at least Tuesdays and Thursdays for flow stuff for now. So I'll try to stick to that and not fall off. But this is going to be a pretty simple run through. I realized at first I didn't really intend to start with the kind of auction project. It was just what I was working on at the time and didn't really have any free time to jump into the playground tutorials back then. So I think this will be a really nice way for everyone to get their feet wet with flow in a pretty slow and steady way. and hopefully questions start coming as we work through these, because we'll start getting to some pretty important stuff pretty quickly. Like by the second step of the Hello World tutorial, we'll start working with resources in Flow and Cadence, which is really like one of the most exciting things about this, and one of the most powerful things about the language in terms of managing your assets. It's one of the things that really makes it a lot different from Ethereum and other languages that still kind of centralize all of the data to one account ledger. This does things a little bit different, and we'll dive into that a little bit deeper once we build our first resource. So I'm not going to go through the entire tutorial article. I think this is super important, especially when you're just getting into the contracts and learning the language. Do take a run through the entire section from welcome to voting. Each tutorial article kind of builds off the last one, so it's really important to understand, you know, the basics of Cadence, why things are the way they are, what types are, how they work, and definitely understand what resources are, at least the basics, before you jump ahead to the next tutorial. So to start with, we're just going to make a really simple Hello World smart contract. This isn't going to use any resources or anything too unfamiliar, I hope, to anybody that's coming from a programming background. So we'll just jump into that right now. I'm not actually going to do any coding. I'll just walk through the pre-assembled code and just kind of touch on some of the important parts here. So you'll see the team has documented things really nicely. So you can definitely take your time going through this on your own, and I do recommend just making sure that you understand every line of code before you move on to the next section, because this does, like I said, take it nice and slow. So just getting started, this is how you'd actually create a smart contract. So the smart contract will be deployed to one of these accounts, and then anytime that we need to interact with it, we'll use either a transaction or a script, and that transaction or script will import the contract code from the account that it's been deployed to. So in this one, like I said, it's super simple. We're creating a public contract named Hello World. Public means that it's available to anyone. So in the case of a smart contract, we want to be able to import the code. That means that we want anyone to be able to access this contract. So using the term pub, you might also see access all in some of the more dated playground code. That essentially means the same thing. So pub shorter, cleaner. That's what you'll probably see on any of the more modern walkthroughs. That's what I use. So the first thing we're going to do is we're going to declare a public field. So again, we're using the pub keyword. We're using let, which means that in this case, this is a constant. So the let keyword, contrary to JavaScript, means that this field or variable can be set once and never changed. So when we initialize our smart contract, we're setting the value of this field to hello world, which is a string, and we'll never be able to change that value again. So once the contract is initialized, this is the value of this field forever. So when you see string here, this is because Cadence is a strongly or strictly typed language. So what that means is this can only be a string. If you try to set it to, say, 0, well, that is an int or an integer. We cannot add an integer to a field that has been typed as a string. So if you've used TypeScript and JavaScript, that should be pretty familiar to you. What's nice about that is it really helps prevent just, you know, head scratchers of bugs from preventing your code from running, even though you're not seeing any errors or issues in the syntax highlighting. So I've definitely found this to be a really welcome change from PHP and JavaScript languages that I've been working with before, because most of the time, if my code looks good and there are no errors in VS Code, I can feel pretty confident that it's actually going to run properly on the blockchain. So just a nice thing to have. It's more of a developer environment and developer tooling thing, but I mean, developer experience is in a lot of ways, in this world especially, just as important as user experience. So it's nice to have things like that. And then so finally we're just going to create a getter method basically, which just returns the value of the greeting. So again, it's a public method. We want anyone to be able to call it. Fun is just our keyword for function or method. And then this is our name for our function. And this is our return value. So if the function is going to return a value, we need to put the type of the value that the function is supposed to return here. If it doesn't return, so again, if it returns an integer or something like that, we would get an error in our code and we wouldn't actually be able to deploy this contract, which is a really nice thing. So we know that we're returning a string, which is what we intend to return. Our code is done. So now we can deploy this contract. So we can see down in our console that our contract has been deployed to account 1. And now the code is living there, and in a real blockchain world, anyone would be able to import that code and run this hello function to say hello to the world, which is super exciting. So we're going to just quickly jump over to the transaction. And transactions are how you either read or write from, I should rephrase that. Transactions are how you read and write from a blockchain. So a transaction, normally you would think of this as something where you're probably going to have to pay a fee. And a transaction would typically be used if I need to manipulate something on the contract, and I can also choose to return a value from it or read data from the contract itself. The difference between a transaction and a script is scripts are just used to read data from the chain. So you don't have to pay a transaction fee to run a script. Scripts are just basically kind of a third party basically saying, hey, what does this mean? And the chain will give you back the data that you've requested from it if it exists. So rule of thumb would be if you just need to read from the chain, don't use a transaction. You'll probably end up having to pay a fee. Just use a script. If you need to read and write, or just write, use a transaction. So in this case, what we're going to do is we're going to import the hello world contract from account 1, which it's already been deployed to, and in the playground we can actually see the name of the contract that we've deployed to the account. So we do that by creating a transaction. Transactions can have a prepare block as well as an execute block. So we're not really doing anything in this prepare block, but the person who assigns, or the account who signs the transaction, we could actually access their account object and run some manipulation or read some data from that account. This is where you'll see this in action in the next step, where we're actually using resources. And then in the execute block, this is where we actually run the code. So if we need to actually execute any code on the transaction, this is where we'd put it. So in this case, the transaction that we're executing, we're just going to log the string or the return value from the hello method on the hello world contract. So again, that hello method just returns the value of the string that we defined up here. So we can run this transaction from any account. So that's our hello world value there. Now I've just changed the signer from account 1 to account 2. We'll send it again. And life's changing. It said the same thing twice. So our code is working. The value will always be the same. We can sign it with any account that we want. We'll get the same value. And that's a pretty basic implementation of a smart contract. Just the nuts and bolts, no resources, and just returning a static value that was set on initialization. So one of the really cool things about Flow is the ability to redeploy your contracts. So it's going to give me a little message saying, hey, it's going to clear the state of all the accounts. Do you want to proceed? Absolutely, let's break stuff. So we've just updated the value of our local field to hello flow and redeployed the contract. Nothing else has changed. But when we run this transaction again, of course, because I'm live, the code didn't change. So let's define another greeting. I'm just dancing around it because I don't know why that didn't update. So we'll create another method. We'll just call it hello flow. It's going to return a string. Okay, almost hit save, but we don't have to do that because we are in the playground. And we don't spell hello with a W unless we really want to. And I hit save. Cool. So we're just going to change this now to use the hello flow. I really want to spell that with a W. Okay, let's see if this works this time. Otherwise, I just need to start from scratch, and we know that it's not deploying the new contract. There we go. So now we're calling our new method on our updated contract. So I'm not sure exactly what happened there, if it's because we tried to change the value of a static field, because we've set it to let, it couldn't be changed. But since we're walking through things and learning together, let's just change this to var. So this in flow means that the value of this variable can be changed. So if we're using a var, let me set this to flow now. Now let's see. I'm hoping that this will work. Let's just redeploy it one more time to make sure I did it. So this should say hello flow now. Yep, there we go. Let's try updating it and see what happens. Hello people. So I'm gonna just clear this out. Oops. I didn't know we could do that, but that's cool. Let's do it. We're gonna run it one more time and see what happens. One more redeploy. This is just me being curious now. Cool. So I wonder if there's a... It seems like I'm having to redeploy twice, and on the second time the state seems to update. So good to know. Might mention that to one of the members of the flow team. So that's calling the method, but essentially this is just reading data from the contract. So what I noticed was that the tutorial had it set up to use a transaction for that, but like I mentioned, if it's read only, we should just be using a script. So I'm just going to quickly execute this script just for another test. Cool. So we shouldn't need to log that. Yeah, we do. So what it's doing is it's logging the response from the hello world method, and then it's also logging the result from the script. So it's returning this void type, which is essentially, if we don't have a type up here, like if we're not returning anything, then it would be a void type, but that's default behavior, so we don't actually need to add that. But that's where that comes from. Okay, so that was pretty quickly just kind of a run through on how to build a contract on Flow. Very basic. So we're not using resources, we're just using local variables, initializing the contract, creating a getter method to return the value of the variable, and then we logged it using a transaction, which is not recommended, and via a script, which would be my recommendation. So again, we're not paying fees to read data from the contract. We don't need to manipulate anything. We don't need to send anything. There's no sense paying for it. So now we get into the fun stuff. We're using resources for the next step, and this is a lot more powerful. So this is a good segue to why I'm excited to work with Flow. I did spend a little bit of time with Ethereum, but without kind of having a community around you and, you know, some better developers to ask, hey, am I doing this right? The thing that really scares me about Ethereum is how much money could I potentially cost people, right? Like, if you look at DeFi and a lot of the other projects out there, like there's so much potential for a bug to just wreck you, right? Like, and take a serious chunk of change along with it, that I just personally, you know, I would feel terrible if I did that to somebody, and I definitely don't want to be on the hook for it. So there's something just beautiful about working with a code base that kind of protects you from maybe the wrong people getting access to the methods that you forgot to hide properly, or just, you know, making it harder for people to you know, bad actors to steal from people, or, you know, basically leaving doors open that you don't want to leave open as a developer. And Flow has been designed with that in mind. So Cadence, the smart contract language for the Flow blockchain, uses these resources, which are objects that can only, like, they're linear types is what the technical term for them is, and they're objects that can only exist in one place at a time. So simply put, if I have a CryptoKitty non-fungible token and it's living in my account, it can't live anywhere else. I have to, I don't want to say physically, but digitally send that somewhere, where then it will leave my account, it will be possessed by the new account, and that account has to then send it somewhere else. And I mean, this sounds really basic, but I mean, at the end of the day, resources are a data type that work really well with what we're trying to do with digital assets. So to back that up, an object typically isn't immutable. Like, you could change that object, you could copy that object, like kind of coming up and having a hard time getting this one out, but leading up to now, it's been really hard to maintain control over digital assets. For instance, if I was an author, I wouldn't want to write an ebook as my only medium for my book, because as soon as that ebook gets out there, people can rip it off, people can copy it, and there's no real, like, serial number. Like, there's really no recourse to go after those people. There's no way to protect my IP and protect my product. And with these digital assets that we've turned into these crypto assets, we have this ownership and agency over them. So when you have a data structure, like a resource that fits so well with something that, you know, can only exist in one place and one time. So you have an issue of something, you have a version of something, you have a token, whether it's a, you know, an actual coin like a Bitcoin, or you have a non-fungible token like it's a CryptoKitty or a Gods Unchained card. That fits really well with this whole resource paradigm of something that can only exist in one place and one time. And as a developer, you have to be really specific about what you're trying to do with that resource when you're sending it around or trying to read from it or use it in your code. You can't just leave it hanging somewhere in your code where it's going to get lost or where it's not handled properly, because Cadence will not let you do that. Again, you won't be able to deploy your contract, or you won't be able to send that transaction, because something still needs to be done with that resource and it still needs to be handled properly. So as a developer, especially one who's very new to smart contracts and blockchain, it's really nice to not have to worry about that type of stuff and just kind of almost have a system have your back in case you do something wrong. So a little bit of a long-winded and poorly articulated take on what resources are, but hopefully I'll make them a little bit more I'll make that a little bit more clear as we go through this example. So for this example, we're going to start off pretty much the same way. We're going to create a public contract, hello world. And then the first thing we're going to do is we're going to declare a resource, which is our hello asset. So this resource will be stored into the creator's account once this contract is initialized, which is a huge difference from the last one. So within this resource, we're going to create a method called hello, and it's just going to return a string that's hello world. So we're not going to set any fields in this for this example. So when we initialize our contract, we're going to create a new hello asset, and you can see right away that we're using a bit of a different syntax now. So this means that we're working with resources. We're not working with other data types called structs or primitive data types or anything like that. We're working with something special, and the team's gone ahead and used a special syntax just to make that much more clear. So anytime that you see an arrow in the syntax and cadence, you should know, okay, I'm working with a resource or something that contains resources, and I need to be a little bit more careful with how I handle this code. And by careful, it just means that you need to take some other steps to make sure that they're being handled properly, otherwise your code won't deploy. So in this case, we're just creating a new hello asset. We're moving it into this new variable or this new field, hello, new hello. And then down here, what we're doing is self account. So the account that stores this contract, or that's initializing this contract, we're going to save it. So this new asset, we're going to save it. Sorry, this new resource, we're going to save it to the hello domain, or the hello namespace in our storage domain for our account storage. So this is basically creating a resource and then saving it into the contract account owner's storage so that we can use it later. And then we're just going to log a little message to the console to let us know that we've done it. So just to start from top to bottom, because I feel like I've gone a little off the rails here trying to explain everything. Creating a new contract. Within that new contract, we're creating a resource. This resource has a method that allows us to just return a simple hello world string. And then when we initialize this contract, so right when it's created, we're going to create a new instance of our hello asset resource, and we're going to save it to the account storage. So we'll go ahead and deploy it. Cool, so we can see it here, deployed contract to account 2. I'm just going to clear that out so we can see it a little better. So nice to see our storage is working, so I can hopefully pull this up and show you what I mean about seeing what we have in storage. So when I say that we're storing it to our account storage, we can actually see hello has a resource, and we can actually see the well, there are no fields for this resource, but we can actually see the data for the resource stored in account storage. So pretty cool. That's one of the nice features of the Flow Playground. So in order to interact with this resource, we're going to need to import the hello world contract from account 2. So this one, not this one, because this one doesn't have a resource. I wish I could clear that out, but we've gone too far. And then in this transaction, we're going to use our prepare block. We're not even going to use the execute block. And we are going to load the hello asset resource from our account storage. So we do have to specify the exact place where we stored it. We're using the account that signed this, so this needs to be signed with account number 1, otherwise there won't be account number 2, otherwise there won't be a resource available in storage, and I'll demonstrate that in a second. And then we're using something called optional chaining for that case. So if there isn't something in storage, it's not going to have a hello it's not going to have this method. So we need to basically account for that in our code. Otherwise, again, the code's going to freak out and it won't actually let us run anything. So we put this little question mark here to basically say if we get something from hello resource, if there's something here to actually put in this variable. So if not, nil would be the term that we use for it. So nil is a value. That basically means that there's nothing there. So if this isn't nil, we're going to call the hello method on it. And then we put it back in storage. So after we're done with it, we save the resource that we pulled out back to the same place in storage. And then we use the force unwrap operator, which is this little exclamation mark or bang. And this just aborts this whole line if hello resource is nil. So if there isn't anything to begin with, we just kill it because we don't want to execute this code. So just to show you what this looks like when it runs, again, I'll just kind of walk through it before I do that. Sorry, but we're going to import the contract from account 2. We're going to create our transaction. We're just using our prepare block here. We don't actually have to execute anything. So we're just pulling a resource out of storage. We're checking if it exists, calling a method on it, and then we're popping it right back into the same place in storage. So if I do try running this with account 1, we're going to get an error because I don't actually have a resource in account 1 storage. So it's saying unexpectedly found nil while forcing an optional value, which is our force unwrap doing its job here. But if we change this to account 2, which actually has the resource that we're trying to load, then we get hello world. So pretty fun stuff, but pretty powerful because now we're actually manipulating resources and we're using them. We're pulling them out of storage, calling a method on them, putting it back, but this actually does demonstrate some of the power that resources actually have and how to basically just interact with them when they're stored in an account. So let me just quickly refer back to our article here to make sure I have a full grasp over what we're going to do in the next step. So this is just running through the one that we did. This is the transaction that we just ran. There we go, perfect. So next we're going to create a reference to the stored resource. And this is pretty powerful stuff. And this is where I would spend a lot of time just kind of getting comfortable with how to use a reference, like, or how to borrow a reference, why we do it, and at least like what I found when I was starting to write contracts was I was moving resources around too much. So I was using this move operator way too much in my code, where essentially what I should have been doing was just borrowing a reference and working on the resource that way. So that might kind of sound a little intense right now, but we'll walk through it and it should start to make sense as we get through this next section here. So we're working from the same smart contract. We're importing hello world from account 2. Creating a new transaction, setting up a prepare block, and then in this case what we're doing, so we're going to create a capability for our hello asset, and we're going to link it to the public storage so that other accounts that don't have direct access to this, so other accounts that don't have this asset in storage can still link to that public capability and call its method. So basically this is why account number 1 wasn't able to run that previous transaction. So when I don't know how to make that go away, but we'll just do this. So I've changed the signer back to account number 1. And we get that error because there's no resource in storage to actually call the hello method from. So at this point, this transaction is only useful for the account that actually stores the resource, which on one side demonstrates just because there's a resource in existence and there's a public method on it, you still have to intentionally give the public access to that resource in order for them to actually work with it or read data from it or something like that, right? Like it's not that once it sits in your storage the world's free to have their way with it. So in this transaction what we're doing is we're linking a capability to our resource so that accounts 1, 3, and 4 can borrow that capability, or borrow a reference to that capability. One more time, borrow a reference to that resource and then call the hello method on it, which then should produce the same result for everyone. So just give me one quick sec to see if I can get through or get away from this console. There we go. It's super cool that it does that. I just wish I could collapse it back, and I'm not sure where if that's a extension feature or if that's a native playground feature. So just to walk through what this code is doing, again, it's really well commented, and I really do recommend walking through the tutorials on your own so that you can read through each and everything, take your time with it, and make sure that you understand every line of code. But we're linking to a reference, which is this ampersand here, to the hello asset that's from the hello world contract. So it's like a namespace. We're linking to a reference to this asset, which lives here. That's the namespace that it's coming from. And then we're storing it at our public domain with a name of hello. And the target, so we're targeting the asset that lives in the storage domain with the name of hello. So again, if you remember back to when we created it, we created our asset and saved it to storage hello. Now we're linking to the asset that we have saved in storage hello and creating a capability that we save to public hello. And then if we can get that capability, so if that capability is not nil, we're going to borrow a reference to it, which is what this borrow method's doing. And if there's a reference, we're going to log the hello method on it. So I think, let's just see. I think I might have misspoke. This might be a step that we need to do before account. I don't think we can run this with account number 1, but we'll try this first. So account 2 will link it, and then it actually borrows a reference to its own asset, and then it calls the method on it. So we know this works because account 2 is the owner of this asset, so it has access to it. It can run this code. I know that it did create the capability because this code wouldn't have run, but what I'm more interested in is what happens when account 1 runs this transaction, because I still think it's going to fail. Account 1 doesn't have the asset in storage, so yeah, so nothing happens because there's no asset for it to link to. It still needs to do all this stuff before it can actually interact with it. But this is the step that we do in order to read from it. So hopefully this is clear and I didn't just create a bunch of confusion about that. This transaction 3, can only be run from account number 2 because this transaction is setting up what we're about to do in the next script. So hello world, the hello asset is stored in account 2, which was the creator of the contract. This is where we stored it when the contract was created. We're linking to that asset, creating a capability, borrowing a reference to that capability, and calling the method on it. But this is the important step right here. So by creating this capability, we're now able to read and log the result of this method from any account. So can't really demonstrate it here because you can't create a signer for a script. Scripts don't have a signer. There's nothing special going on. We don't need any special account access. All we need to do is designate what we're trying to do and where it exists, and run the code. So in this example, we're again excuse me, importing the hello world contract from account 2. We're actually getting the public account object for account 2. So we're saying, hey, I want to know, everything the public is privy to about this account. On that public account object, we can get the capability that we just created in transaction 3 from public hello, and then we can borrow a reference. So again, we're going to borrow a reference. Here is basically just saying this is the type of reference that we're trying to borrow. So it's a reference to the hello world hello asset resource. We're only going to borrow that reference if the hello capability exists. So if it's nil, we're going to kill this code and stop it in its tracks. And then if it has the method hello, we're going to log the result. Otherwise, this would just log nil. But when we execute, we'll get hello world. We'll also get that same void message that we got from the last time we logged a script. Again, that's just basically giving you back the result of the actual script itself, not the log data that we're trying to access in the contract. But this can be run from any account. So I could be using account 01, I could be using 04. It's just completely kind of external third party, demonstrating the fact that the public capabilities were linked for the hello asset. So that is a pretty quick demonstration of the hello world tutorial. I really, I do highly recommend running through it by yourself, and taking your time with it, just to go line by line, play with a few things, try to break it. Like, that's the best way to learn with anything new, is just rip through, change values, try to break it, see what kind of errors you turn up. Tell the team if there any errors don't make sense, because they're just as interested in what kind of bugs and issues we run into. The chain is still in its test net. It hasn't been released to the public yet. We're just starting to build for it, so it's a really exciting time. I fully encourage you to jump over and get your feet wet, because there's never a better time to learn tech. The language is also pretty cadence. I'm referring to is pretty young, still in development, and changes are happening pretty fast and furious. So it's not a very overwhelming language to learn. And the faster you get into any new language, the sooner you start learning the ins and outs of it, and really knowing what tools you have at your disposal. So this is a smart contract platform, or a blockchain that's built for the non-fungible token space. This is, in my opinion, it's gonna be huge for gaming and collectibles, arts, music, all sorts of stuff. I'm pretty sure you're gonna find a home on Flow. And if the transactions are as fast and cheap as the team hopes they will be, this could become a massive DeFi platform as well. So tons of opportunity in this space. Highly recommend getting started. Jump into the Flow Discord, start asking questions, introduce yourself. You'll find a super welcoming community. That's probably one of my favorite things about Flow. So just get involved, join the team, ask some questions, and start building. That'll be it for today. It's a pretty quick stream. Hope this was helpful. Feel free to reach out in the comments, make some suggestions for projects that you want to work on. I am probably just gonna jump into the fungible token example. We'll do that this week. That'll be a little bit more interesting, because we're actually gonna get into a light use case for fungible tokens. So basically building like an Ether or Bitcoin simple kind of version of a token that you'd be able to withdraw and deposit and transfer back and forth. So pretty cool stuff. It starts getting real next stream. Please do take a jump through and familiarize yourself with the Hello World tutorial before jumping into the next one. And I hope to see you here for the next stream. We're gonna pencil it in for tomorrow, probably around 3 p.m. Pacific time. I will try to stick to that. And till then, have some fun, build something cool, and I'll see you then.